Chemistry is a huge part of medicine, both a diagnostic and treatment tool. Chemistry departments in hospital medical labs analyze blood, urine, etc. for proteins, sugars, and other metabolic and inorganic substances. Electrolyte tests are a routine blood analysis testing things like potassium and sodium. Most medicines are involved in inhibiting a specific enzyme or the expression of a gene. Blocking an enzyme's active site requires a specifically designed blocker to disable the enzyme's function. Since enzymes are proteins, their functions differ based on shape and inhibitor drugs, such as to be customized for each target enzyme. This requires chemistry. While the concept of RNA interference is more on the biological side, the engineering of chemicals to inhibit the translation of mRNA into an amino acid sequence by ribosomes requires chemistry. An RNAi, a designed piece of double-stranded RNA, literally chops up mRNA to prevent from undergoing translation. Another example of chemistry used in medicine is chemotherapy, which is a controlled use of chemicals for a medical purpose. The term was coined by a German bacteriologist around 1900 when he examined aniline dyes and arsenicals as possible treatments for diseases such as trypanosomiasis and syphilis. He envisioned magic bullets that could target invading organisms and leave the host unscathed. This goal of providing therapeutic benefits with minimum side effects continues in all areas of drug development. Remarkable successes have been obtained in compounds that modulate normal biochemistry within the body. The battle against the unwanted growth of invaded organisms and mutated cells, such as cancer, the greatest successes have occurred in the bacterial and antibiotics. In the 20th century, they have increased human longevity more than any other medicine. Similar successes for drugs treating viral infections and cancer have been elusive. Lots of could-be medicines look good on paper or even on a computer screen, but a drug can only do its intended job of treating a symptom or fighting a disease if it gets the right place in the body to do its job. That's where chemistry plays a big role, in tweaking molecules to interact appropriately with the body. A lot of the most important medical processes in recent history has come from the development of powerful antibiotics and vaccines to treat infectious disease caused by bacteria, viruses, and parasites. But those breakthroughs have come with a cost. Microorganisms are learning to fight back. The misuse of antibiotics is the most common reason why antibiotic resistance is such a significant public health problem. These drugs are sometimes prescribed way too much by doctors, and many people fail to finish the full prescription. Chemists are well aware of the public health danger posed by MRSA and other resistant organisms. They are working hard to outwit microbes to develop resistance. New forms of antibiotic drugs are currently in the pipeline, and researchers are trying to design them to target vulnerable macro regions of enzymes within bacteria.
It's the Speaker Knockers.